students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as LPP. So let's see this. They will give you a sum like this. Maximize z is equal to 5x plus 10y subject to x plus 2y is less than equal to 10, 3x plus y is less than equal to 12, x is greater than equal to 0, y is greater than equal to 0. Right? Now, whatever they give you after subject to, that is called as constraint. So I'll say for constraint 1, x plus 2y is equal to 10. Right? You make a table like this. X, y, 0, 0. Right? Now, if x is 0, then 2y is equal to 10. Therefore, y is equal to 5. If y is 0, then x will be equal to 10. Right? Then similarly, I can say for constraint 2.
So could you repeat how you did that?
If x is equal to 0, if I take x as 0, then 2y becomes equal to 10.
Yeah.
Y will be 5. If I take y as 0, then x becomes equal to 10. Right? See, I'll show you another equation like this. 3x plus y is equal to 12. X, y, put 0 and 0 here. See this. If x is 0, then y will become equal to 12. If y is 0, then 3x is equal to 12. Therefore, x is equal to 4. Now, guys, either you will get a graph paper or you may not get a graph paper. So, what I'm going to teach you right now is how to draw LPP without a graph paper. Right? With a scale, you have to take exact measurements and draw 1 centimeters. On x-axis, you need up till 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And on y-axis, you need up till 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Now, x is equal to 10. This is that point. We will call this point as 10, 0. Y is equal to 5. This point is B, which is nothing but 0, 5. Now, in that case, right, draw a line joining them. Right? This line will be x plus 2y is less than equal to 10. If I say less than, that means I need to shade the portion behind. Right? So, do we understand this? So, the first thing that you need to do is plot the points out. Right? Next, similarly, x is equal to 4. So, this is going to be that point C, which is going to be 4. Which is going to be 4, 0. And this is that point D, which is 0, 12. Draw a line joining through them. This line is, this is C 4, 0. And this line is 3x plus y is less than equal to 12. Less than means behind the line. Less than means behind the line. In both the cases, there is less than. Less than means behind both the lines. Right? So, what is the common region? This is going to be your common region. This common region is called as feasibility region. Right? Once you get the feasibility region, then you find out your corner points. First of all, let's find out this point of intersection. How do I find out the point of intersection? I find out the point of intersection by solving the two equations simultaneously. So that means x plus 2y is equal to 10 and 3x plus y is equal to 12. Solve these two equations simultaneously. Multiply this equation no, multiply the second equation by 2. So I'll get 6x plus 2y is equal to 24, and the first equation was x plus 2y is equal to 10. Subtract the two equations. If I subtract the two equations, all my signs will reverse. So I'll get 5x is equal to 14. So x is equal to 14 upon 5. 5 2s are 10, 8, 2.8. Once I get the value of x, substitute the value of x in any one of the equation. So I'll get 2.8 plus 2y is 10. So 2y is 7.2. Therefore y is 3.6. Now let's look at your feasibility region. Your feasibility region has 4 points. O, C, we'll call this point as E and B. Right? We just found out the coordinates of E to be 2.8, 3.6. So I'll say corner points, subjective function. Right? Now my corner points are O, which is 0, 0, C, which is 4, 0, E, we found the coordinates of E to be 2.8, 3.6, and last is B, which is 0, 5. Your subjective function, initially what they asked you to maximize is your subjective function. So your subjective function is going to be z is equal to 5x plus 10y. Substitute these values of x and y. So I'll get 5 into 0 plus 10 into 0, which is 0. This is 5 into 4 plus 10 into 0, 20. 5 into 2.8 plus 10 into 3.6. This is 14 plus 36, 46, 50. This is 5 into 0 plus 10 into 5, that is 50. What have they asked you to do? Maximize. Which is the maximum value of 50, right? So you can therefore say that the maximum value, you can say that maximum value is 50. Maximum value is 50 when two conditions, when x is 2.8 and y is 3.6, or x is 0 and y is 5. Fine, did we get this thing here? So that's how you solve the sum. Let's see another sum of this kind, guys.
So,
yeah.
So the x greater than 0 and y greater than 0
indicates that
that's why it's above the origin.
Yeah, that's the reason why it is in the first quadrant. Right? Next, let's see another sum. Minimize. Minimize z is equal to 3x plus y subject to 2x plus 3y is less than equal to 6. X plus y is greater than equal to 1. X is greater than equal to 0, y is greater than equal to 0. Right? Same thing. First you will say for constraint 1, method remains the same whether it's maximize or minimize. For constraint 1 is 2x plus 3y is equal to 6. You here write only equal to sign, don't write the inequality here. X, y, 0, 0. Right? Now, if x is equal to 0, then y will be equal to 2 because 3y is equal to 6. If y is equal to 0, then x will be equal to 3. Then similarly I can say for constraint 2, x plus y is equal to 1. This is going to be x, y, 0, 0. If x is 0, then y is 1. If y is 0, then x is 1. Now draw your graph. X-axis, y-axis, origin. On x I need 3. So 1, 2, 3. On y-axis I need 2. 1, 2. Right? Now let's see this. X is 3. So this is going to be that point 3, 0. And y is 2. So this is going to be b 0, 2. Join this. Right? If I join this will be nothing but 2x plus 3y is less than equal to 6. Less than means it has to be behind this line. Next, this is going to be that point C. This is going to be that point C, which is going to be 1, 0. This is going to be that point D, which is 0, 1. Right? In which case I'll get x plus y is greater than 1. Greater than 1 means above this line. So which is the region which is common to them? The region which is common to them is this. Since the two lines are not intersecting, I don't have to solve the two equations simultaneously. Straight away I can say corner points and subjective function. Corner points are your corner points of your feasibility region. This is your feasibility region. Right, your feasibility region is going to be C, A, B, D. C is 1, 0, A is 3, 0, B is 0, 2 and D is 0, 1. Subjective function Z is equal to 3x plus y. Substitute. So you will get 3 into 1 plus 0. This is 3. Your Z will be equal to 3 into 3 plus 0, which is 9. Your Z will be 3 into 0 plus 2, which is 2. And here Z will be 3 into 0 plus 1, which is 1. What have they asked you to do? Minimize. So in that case I can say that minimum value is 1 when x is equal to 0 and y is equal to 1. Fine, did you get this thing clear? Next, minimize. Z is equal to x plus 4y subject to x plus 3y is greater than 3 and x plus 2y is greater than 2 and x is greater than 0, y is greater than 0. Right? I can say for constraint 1, constraint 1 is x plus 3y is equal to 3. X, y, 0, 0. Right? Let's see this. X is 0. If x is 0, then y will be equal to 1. If y is 0, then x will be equal to 3. Right? Same thing now I can do for constraint 2. I can say that for constraint 2, I can say that x plus 2y is equal to 2. X plus 2y is equal to 2. In which case I can say that this is x, y, 0, 0. If x is 0, then 2y is equal to 2, therefore y is equal to 1. If y is equal to 0, in that case x will be equal to 2. Right? Once I have this value of x and y, then I can say that, right? Then I can say that, let's make the graph. X, origin, y, right? X axis is 1, 2, 3, 1, 2, 3, y-axis is nothing but 1 and you just make a 2 here. Okay. Now let's see this. First point is x is 3. So this is going to be that point A, 3, 0, and y is 1, B, 0, 1. Right? So this is going to be that line. Now we are saying greater than. Greater than means it has to be ahead of this line. The equation of this line is x plus 3y is greater than equal to 3. Next, x is 2. X is 2. So this is going to be that point 2, 0, and y is 1. So same point it goes through. This is going to be that line. This line is going to be x plus 2y is greater than 2. Greater than 2 means it has to be ahead of this line. In both the cases, it's going to be ahead of the line. So your feasibility region is going to be this region that is going to be ahead of this line. Right? There are going to be only two corner points, 1 and 2. So I can straight away say corner points, they are not intersecting, they are intersecting at point B. So there is no need to solve simultaneously. Corner points, subjective function. Right? Corner points A is 3, 0 and B is 0, 1. Right? Substitute. Z is equal to x plus 4y. Z is equal to x plus 4 into 0. So this is going to be 3. And here x is equal to 0 plus 4y. 4 into 1. That is going to be 4. They have asked you to minimize. I can say therefore minimum value is 3 when x is 3 and y is 0. Right? Do we get this thing clear? Next, let's see this. Maximize. Z is equal to 6x1 plus 7x2 subject to 2x1 plus 3x2 is less than equal to 12. 2x1 plus x2 is less than equal to 8. x1 is greater than equal to 0, x2 is greater than equal to 0. Right? Now let's see this. For constraint 1. (2x1 plus 3x2) is less than equal to 12. So let's see this. You just write this as equal to 12. x1, x2, 0, 0. Right? 2x1. If I take x1 as 0, then I will get 3. x2 is equal to 12. So x2 will be equal to 4. If I take x2 as 0, then x1 will be equal to 6. Now I can say for constraint 2, constraint 2 is 2x1 plus x2 is less equal to 8. x1, x2, 0, 0, right? x1, so that means x2 will be equal to 8, x2, so x1 will be equal to 4, right? Once you have this, I can draw the graph, guys. Now, on x-axis, I need 6, so this is going to be my x1 axis, 1, 2, 3, 4, 5, 6. Remember guys, you have to draw this with proper scale. Okay. Then on y1 I need up till 8. 1, 2, 3, 4, 5, 6, 7, 8. Now x1 is 6, so this is going to be that point 6, 0. x2 is 4, so this is going to be that point 0, 4. Right? Where I can say 2x1 plus 3x2 is less than equal to 12. Less than means it has to be behind. Next, x1 is equal to 4. So this is going to be that point 4, 0. And x2 is going to be equal to 8. This is going to be that point that is going to be 0, 8. Right? So I'll get this as 2x1 plus x2 is less than equal to 8. Less than has to be behind this line, behind this line. So the common region is going to be this. This is going to be, guys, my feasibility region. Your feasibility region is made up of 4 corner points. O, C, we will call this point as E and D. Now let's try to find the coordinates of E. How will I find the coordinates of E? To find the coordinates of E, I have to solve the two equations simultaneously. So I'll say 2x1 plus 3x2 is equal to 12 and 2x1 plus x2 is equal to 8. Right? Now in that case, I can straight away subtract the two equations. If I subtract the two equations, minus, 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 so in that case this will be 2x2 is equal to 4. So x2 will be equal to 2. Right? Once I have this, substitute x2 in any one of the equations. Say let's assume I substitute in equation 1. So I'll get 2x1 plus 6 is equal to 12. 2x1 is equal to 6. x1 is 3. Therefore, I can say that the coordinates of E are 3, 2. Once I have this, then I can say corner points and subjective function. Corner points are O, C, E and B. 0, 0, C. C is going to be 4, 0. E is going to be 3, 2. B is going to be 0, 4. Right? Z is nothing but 6x1 plus 7x2. So if I substitute, I'll get this as 6 into 0 plus 7 into 0, which is 0. 6 into 4 plus 7 into 0, that is 24. This is going to be 6 into 3 plus 7 into 2. 6 3s are 18 and plus 7 into 2, 14. So 18 plus 14, this is going to be 18 plus 14, 28, 32. And here Z is going to be nothing but 6 into 0 plus 7 into 4, that's 28. Right? The largest value here is 32. So therefore I can say that maximum value is equal to 32 when x is equal to 3 and y is equal to 2. Right? Do we get this thing clear? Next, let's take on next one, guys. 6x1. Next, maximize. Z is equal to 3x1 plus 11x2 subject to 2x1 minus x2 is less than equal to 2. x1 minus 4x2 is less than equal to 4. x1 is greater than equal to 0, x2 is greater than equal to 0. Right? Now, let's see this. First of all, I can say for constraint 1, constraint 1, 2x1 minus x2 is less than equal to 2. So we'll just write this as equal to 2. x1, x2, 0, 0. Now if x1 is 0, then x2 will be minus 2. If x2 is 0, x1 will be equal to 1. Now I can say for constraint 2, constraint 2 is x1 plus minus 4x2 is equal to 4. x1, x2, 0, 0. If x1 is 0, then minus 4x2 is equal to 4, so x2 will be equal to minus 1. If x2 is 0, then x1 will be equal to 4. Now, see the graph for this, guys. I have both on x2. Okay. This is your x1, this is x2, right? This is going to be equal to 1, 2, 3, 4, 1, 2, minus 1, minus 2, right? Now x1 is 1, so this is going to be that point A, 1, comma 0. x2 is minus 2, this is going to be that point minus 2, comma 0. So in that case, this line will be like this. Equation of this line is 2x1 minus x2 is less than equal to 2. Right? Next, x1 is 4. C is 4, comma 0. D is nothing but minus 1, comma 0, comma minus 1. So in which case, you will get this here. Right? Now, they have said that this is, in the sum they have said 1 is less than, 1 is greater than. Guys, just make this correction. In the sum they have said that for the first line it is less than. Less than means behind this line. This should be the shaded region. Ahead means ahead of this line. In the first quadrant we see that the two shaded regions do not meet. Since the two shaded regions do not meet, there is no optimum value. Since the two shaded regions do not meet in first quadrant, there is no feasible solution. Right? Let's see this. Next, sixth. We've done this. Next is minimize. Minimize z is equal to 6x1 plus x2 subject to 2x1 plus x2 is greater than equal to 3, x1 minus x2 is greater than equal to 0, x1 is greater than equal to 0, x2 is greater than equal to 0. Same thing I can say for constraint 1. For constraint 1 I can say that 2x1 plus x2 is equal to 3. So in which case I can say that x1, x2, 0, 0, right? x1 is equal to 0, so x2 will be equal to 3, x2 is equal to 0, so x1 will be 3 by 2. For constraint 2, x1 minus x2 is equal to 0. Now here guys you have to pay attention. Here you cannot follow the normal rule. This is x1, this is x2. Here if you take 0, 0, you will not get the points. When you have an equation where your right hand side is 0, in that case Generally what we used to do, we used to take 0, 0 here and here. But that you cannot do when your right hand side is 0. In that case you have to take points 1 and 2. If I take x1 as 1, then x2 will also be equal to 1. If I take x1 as 2, x2 will also be equal to 2. So when your right hand side is 0, you do not take your points as x and y coordinate as 0, but you take them as 1 and 2. Let's draw this graph.
But why do you make it like that?
Because if I take 0 and 0, then I will not get the points only.
No, sir, no. First constraint.
First constraint, you always take it that way, na? If x1 is 0, then x2 will be 3.
Oh, okay, yeah, sorry.
Right? Now let's see this. 1, 2, 3, 4. That's on x1. On x2, 1, 2, and 3. Right? Now, x1 is 1.5. So x1 is 1.5. So this is going to be a 1.5 comma 0. And x2 is 3. So this is going to be that point b 0 comma 3. Join this. So if I join this, I'll get this equation as 2x1 plus x2 is greater than 3. Greater than 3 means it has to be ahead. Now, x1 is 1, x2 is 1. This is going to be that point C where you have 1 comma 1. This is going to be the point C, 1 comma 1. And x2 is 2 and x1 is also 2. So this is going to be that point D, which is 2 comma 2. Join this. You will get a line like this. This line is x1 minus x2 is greater than 0. Greater than has to be ahead. So this is going to be my feasibility region. Right? In that case, I can say that 2x1 plus x2 is equal to 3 and x1 minus x2 is equal to 0. Add the two equations, I'll get 3x1 is equal to 3. So in that case, I'll get x1 is equal to 1. x1 is equal to 1. Right? Substitute. Therefore, I'll get x2 will also be equal to 1. Once I have the value of x1 and x2, then I can say that, therefore, coordinates of point E, that's your point of intersection. Coordinates of E are 1, 1. I can say corner points, and I can say subjective function. Corner points. Which are the corner points? Corner points are nothing but A 1.5, 0 and E. There are only two corner points. E, which we found out is 1, 1. Okay. Your subjective function was 6x1 plus x2. Z is equal to 6x1 plus x2. So this is going to be 6 into 1.5 plus 0. That's going to be 9. And this is going to be 6 into 1 plus 1. That's 7. So you would say therefore minimum value is equal to 7 when x1 is equal to 1 and x2 is equal to 1. Right? We'll stop this here for the day. Thank you very much.